Hi, welcome back sa aking channel. So para sa vlog na to, gagamit tayo ng simulation software na PSpice para i-perform yung experiment na ito. Ang title ng experiment na to ay Instantaneous Power, Energy, and Average Power using PSpice. So objectives ay to simulate power electronic circuits to determine the voltages, currents, and power quantities, and to utilize the functions to measure the energy and steady-state RMS current. So, para sa procedures, part 1, unang-una ay open the ORCAD Capture PSpice and click the new project. So, ito yung ORCAD Capture PSpice, new project, tapos choose the analog or mix A/D and then name it as experiment 1. Palitan na lang natin ng experiment 2. So, experiment 2, A/D, tapos okay. And then, gaya last time, create a blank project, tapos okay. Ayan. Create the circuit as shown below. So, dito merong voltage source na sign, tapos isang resistor tsaka ground. Place PSpice component, source, voltage source, tapos sign. Tapos place resistor, rotate, control R, and then press G para sa ground. Yan. Zoom natin. Press W para sa wires. Connect yung mga dulo. And then, set na natin yung values. Ang V off ay 0. Ang amplitude ay 10. Frequency ay 60. So, 0, 10, at 60. Sa AC, wala namang nakalagay. So, 0 na lang din. Yan. Ang value ng resistor ay 5. Okay. So, for reference, palitan na lang din natin yung pangalan ng R load. Ayan. Use V-sin or V-sign for the source. Set the voltage source amplitude to 10 volts and frequency to 60 Hz. And the resistor to 5 ohms. So, ayun, okay na, nagawa na natin. Ang sunod ay, select the time domain transient in the simulation setup and then enter a runtime or time to stop of 16.67 milliseconds. So, na-explain ko na to nung unang-unang video kung bakit merong 16.67 kasi ang reciprocal ng 60 Hz, 1/60, ang magiging sagot nun ay yung 16.67. So, dun nangyayari yung isang period kapag 60 Hz yung frequency ng source. So, para madali nating ma-analyze yung output, dapat isang period yung lalabas dun sa ating graph. Kaya, edit simulation software, experiment 2, part 1. Ayan. And then, 16.67 milli. Okay. Tapos nakalagay dito, result should be like in figure 5. Explain the result. So, ito yung figure 5. So, nakalagay dito, merong power ng load, merong voltage ng source, at saka merong current ng load. So, ngayon, gagamit ulit tayo ng mga probe. So, ito ay power dissipation marker para sa load. Tapos, voltage level marker para dito sa voltage source. Tapos, current marker para dito sa current ng ating load. So, run na natin. And then, ayun. So, kita naman natin. Balik tayo dito sa figure 5. Ayan, parehas naman sila. So, ang explanation nito ay itong kulay blue na graph or waveform, ang kulay blue ay current ng load. Itong kulay pula ay voltage ng source. Tapos itong green ay power ng load. So ngayon, bakit ganyan yung itsura nila? So makikita natin, in phase naman. Sabihin, kung saan tataas, doon din tataas yung isa. alalahanin natin yung formula ng power, which is voltage times current. So, makikita natin dito, pag gagamit tayo nitong cursor or yung marker para masukat natin yung instantaneous values with respect to time, pindutin natin, and then lagay lang natin dito sa pinaka-peak. So, ayan, makikita natin ang voltage ay 9.995, tapos ang current ay 1.999. Pag multiply natin itong value ng current at saka itong voltage, ang magiging sagot ay approximately ito, yung power. So, kahit saang instant, kahit saan dito, kahit dito sa taas, kahit dito sa banda dito, laging ang sagot dito sa power or itong reading ay product siya nitong dalawa. So, try natin ngayon. Dito sa instant na to, labas tayo ng calculator. Ang value ng current ay 1.2525 times ang voltage ay 6.2623. 6.2623. Ang sagot ay 7.843. So, ayun, approximately, malapit siya dito sa ating power value. So, dito naman, sa kabilang side, syempre negative na yung current natin, at negative na din yung voltage. Pero makikita natin, positive pa rin yung power. So, bakit? Kasi di ba pag multiply mo naman yung dalawang negative, ang sagot pa rin ay positive. Ayun. So, yun yung explanation dito sa graph na to. So, next, nakalagay dito, click trace, add trace, and another window shall appear as shown below. Then, under the analog operators and functions, click average. So, papalabasin daw natin ay average power ng load. Add trace, and then average dito sa function, tapos power ng load. Yan. Yan. So, ito yung dilaw, siya ay power ng load. So, ngayon, makikita natin, simula siya sa 0 kasi nga, sign. So, pagdating ng banda dito, aangat siya ng kaunti, tapos dito, stable na siya or steady state na siya. So, pag sinukat natin yung average power, matatagpuan natin yun sa dulo ng isang period, which is dito. Ang power ay 10.07 watts. So, yun yung average power. Para sa next part ng experiment, part 2, ayan, create another project but this time using the circuit shown below and then explain the result. So, ito daw yung circuit. Baligawa na lang tayo ng bagong project para hindi tayo close, new project, experiment 2 part 2. Okay, create a blank project. Okay, tapos ito ay pulse voltage source. Place PSpice component, source, voltage, and then pulse. Ayan. Tapos, isang resistor at isang inductor. Rotate. Ayan. Press G for ground. Tapos, place W to place wire. Oops. Ayan. Okay. Zoom natin. And then, palitan na natin yung parameters. Dito ay 0, 20, 0, 0, 20, 0, 1 nano, 1 nano, and then 80 at 20 milli. Oops. 8 and then 20. Okay? Tapos ang ohms ay 2 at 10 millihenry. Oops. 2 tapos 10 milli. So, ayan. Utilize the function in the simulation to display the current in R1 and steady state RMS current. The output should be like the figure shown below. Explain your simulation output. So, ito dapat yung magiging output. So, run natin. Yung simulation profile pala. experiment 2, part 2, 8, and then... So, sabi dito sa figure 8, hanggang 100 millisecond yung graph. So, ang nalagay natin dito ay 100 millisecond na. Ayan. Apply and then, okay. Tapos, run. Then, lalabas to. Tapos, sabi doon, current ng R load at saka RMS ng R load. So, add trace. Ang current ay, alisin natin yung voltage and power. Current ay ito. Yan. Tapos, RMS. Scroll natin. RMS. Tapos, pilitin ulit natin yung current. And then, okay. Yan. So, katulad na siya. Tama? Yan. So, makikita natin dito, ang peak value nung current ng load ay 8 amperes. So, dito, makikita natin, biglang tataas yung current, tapos pagdating ng 8 amperes, dahan-dahan na siyang bababa. Tapos, hanggang mag-repeat ulit yung cycle. Para dito sa RMS ng current, makikita natin na mag-i-start siya sa 0 and then papalo siya ng around 6 amperes. And after nun, magiging steady state na siya at around 4 amperes. Ayan. 4 and then 4 and then 4. Conclusion. ORCAD PSpice was used to simulate and perform the experiment. Instantaneous average and RMS values of various parameters were measured using the probe and trace functions of the software. For the first part of the experiment, a purely resistive circuit was created, which has a noticeable characteristic that the supplied voltage and current are indeed in phase with each other. The graphs of source voltage, load current, and load power were obtained. As observed on the graph, the power reading from the load at any time instant is always the product of the source voltage and the load current. For the second part of the experiment, an RL circuit was created, which is basically an inductor connected in series with a resistor. The graph of the load current and its RMS were obtained. It was observed that the output waveform from the load current graphically represents a sawtooth wave with a cycle occurring at every 20 milliseconds. Thanks for watching.